Hi everyone, this is David. I just wanted to throw out a proof um, out there and just let you take a look at this and make sure that you are asking appropriate questions of the students, and also to make sure that students aren't making these mistakes. So um, first thing I wanted to point out was that this parallelogram written right here is a parallelogram, and we can prove that this is a parallelogram by by proof. However, um, we cannot say that these two triangles are congruent yet. We can't do it the normal way because here's an angle side relationship, and we know that the angle side is not one of the theorems that we use to prove that two triangles are congruent. So on your quizzes or on your tests, you do not want to ask the question, is this a parallelogram? Rather, you could ask the question, can you prove these triangles are congruent? And in that case, the student, well, they can say, no, you can't prove it by side-side angle, but they are congruent, and this is a parallelogram. And I'll show you that in the proof. So, so that's what I first wanted to talk to you about. So let's look at the proof. Given that we have one set of opposite angles congruent, one set of opposite sides are congruent, let's see how we can make this a parallelogram. Well, the first thing that we'll do is we will extend this side so that it is a little bit longer, and what we'll do is we'll construct a perpendicular line to that point. So we've made a little right triangle here. Construct an interior, and I don't like that color. I like green, so we'll use green. Okay, move this down a little so that we can see what we're working with. Okay, and what I'll do is I'll do the same exact thing here, construct a ray, and then I'll go perpendicular there. So I will construct a triangle interior, and I like the color green. So these two triangles are congruent, and the reason that they are congruent is that we have a right angle. Okay, by construction we constructed a right angle there, and then so that's the hypotenuse, and we know that if this angle DCB is the same as DAB, then that implies that the supplements are going to be the same. Okay, so now these two triangles are proven congruent by angle, angle, side. If those two triangles are congruent, then I can have this guy here. I'm going to label him, let's label him with see if I can pick up, I can't pick up that letter for some reason. Let me see, back up some, and I'll just use a small letter here, small letter A, and I'll use this one as B, and we know that A plus B is some length, and we know that that segment there is congruent to this segment down here. So therefore, I can name this one with an A. So, and then this side BC, if we didn't know what it was, we'll call it side C. Okay? So we should see that A plus B is equal to A plus C. Well, if they're supposed to be equal, then that automatically implies through algebra that B and C are equal there. So we're going to make those congruent, and we have just proven that this is indeed a parallelogram because a parallelogram has both pairs of opposite sides congruent. So I hope that's helpful to you teachers. Please make sure that you're not asking whether or not this is a parallelogram. Well, if you do ask that question, then the answer is actually yes. But if you ask, can you prove the triangles are congruent by one of our big five, I guess you would have to say no in that case. So there you have it. I hope it was good for you, and we'll talk to you soon.